everyone. Now I'll be explaining about my major project, that is SIM2AIR synthetic aerial dataset for UAV monitoring. These are the contents which is included in my presentation. Abstract. In my project, I used approach to generate a synthetic aerial dataset for application in UAV monitoring. So I have a different diverse dataset with photorealism images such as shape, pose, lighting, scale and viewpoint. And I use 3D modeling software Blender to create a synthetic dataset. We'll be using YOLO and Faster RCNN algorithms for detecting the drones. As a conclusion, we'll be seeing how drones will be detected in a synthetic dataset. Introduction. What is UAV? It is the unmanned aerial vehicles which involves protecting a specific area. As the number of UAVs in the world increases, it is becoming an essential part of all high security areas. So monitoring a UAV with the real world images is being difficult. So we'll be creating a synthetic data set. Unlike a real data, which is expensive and time consuming, synthetic data is automatically generated in unlimited quantities. Literature survey. Here I collected few literature surveys which are similar to my project. In this paper, they discussed about analyzing the object detection performance using the synthetic data and real data. They tested how much real data they actually need to train the algorithm. Survey. Here they are using how accurately we can detect the humans using 3D localization with synthetic training data, and they use some YOLO and RGB algorithms. The third literature survey, here they are training deep networks with synthetic data. Here they are using a domain randomization to create a synthetic data. And in the fourth literature survey, here the domain randomization is used for transferring the synthetic data to the real world. Existing system. For UAV monitoring, we are creating a synthetic data which is highly accurate and which is resistant to human error. It satisfies all the desired versions of real data and generated automatically with unlimited quantities. Proposed system. The main focus is to create a synthetic aerial dataset for UAV detection considering different imaging conditions and environments. The other two major challenges in aerial object detection is long-range detection and detection under challenging illumination. The advantages of this system is shape-based representation is achieved by randomly assigning the textures to the performance of aerial object detection. The next one is quantitative and qualitative results show that with different situations and difficult lighting and object detections, synthetic data set is used to detect the drones. Algorithms which are used in my project, YOLO V5 and YOLO V8, which is used for object detection in real time, and it gives a greater accuracy. And here the faster RCNN is used where we have to train the model manually. Compared to other two algorithms, I got 97% accuracy for YOLO V5 algorithm. So this is the system architecture and data flow diagram. We import the libraries, verify the data, explore the data set, image processing is done. We pre-train the model, build the model and train the model. Final outcome will be predicted. Execution. As you can see here, these are the output dashboards. So here I'll be explaining the code. So first we'll be importing the libraries. I'll be cloning the YOLO-v5 repository. Later I install the YOLO-v5 requirement files, and here it will be train the images and validate the images. In the next block of code, I'll be downloading the dataset in a YAML file and train the YOLO-v5 model. In this particular block of code, we'll be getting the box loss, object loss and class loss of the image, and it will be predicting the accuracy of the model. So we got accuracy of model as 97%. Here now we'll be using the YOLO V8 model. YOLO V8 model, the performance level increases with less time, but not sure that whether the accuracy will be greater than YOLO V5 or not. So performance level will be increasing, but we can't predict that accuracy might be greater than other YOLO algorithms. So we'll be getting a accuracy for YOLO V8 model as 96%. So here is the accuracy of the YOLO V8 model, and here is the algorithms and graphs for YOLO V8: confidence curve, precision recall curve, and confusion matrix. Later, we'll be running RCNN, that is faster RCNN. So we need to load manually everything. For this model, we need to call which function to be called, and which randomization image we should be assigned. So here we'll be getting everything in a manual manner. So in this particular block of code, that we define the height, width of the image. We create separate class for each, and data augmentation will be done on the images. So data augmentation is nothing but to draw the image, and we crop the image for particular height or width and define the axis of each and every image. Here we are training and testing the images, and as a final output we'll be getting the accuracy of RCNN model. We define RCNN model and train the model for each every 10 iterations. So we get the loss and the accuracy score. So accuracy score for RCNN is 80%. So this is the model performance of YOLO V5 and YOLO V8, and here it is map value of YOLO and RCNN. As we can see, it is 80%, 96% and 97%. YOLO V5 got the highest accuracy score compared to other algorithms. And next I'll be explaining the front end part of my project. So first I'll be importing the all libraries NumPy, IO, OS and Torch. So we are using YOLO V5 model as we got higher accuracy for this model. So in this particular block of code, it is used for a live webcam detection of drones. As in my project, I can't give a live drone images, so I'll be using the images. So it captures the images and divides it into the different frames. Within a fraction of seconds, the images will be turned into the pixels, and the prediction will be defined into the response cell. So here image is directly passed to YOLO. If we request the file and upload it and passed it to the model, we'll be getting the image and detection of the drone. And all this block of code is for HTML, that is for sign in, user, password, and with different templates are included in this code for my user interface. Here I'll be showing how my code will be executed. So I'll be copying the path of my project code, and I'll be giving python app.py where my front-end code is stored. Then it will be generating a link, and I have to copy this link in a Chrome. So here the link has been generated. I'll be copying it and I'll paste it in Explorer. So as we click on the link, we'll be getting our dashboard. So this is the home screen where all faster RCNN, YOLO V5, YOLO V8, it will be explaining what are these models. And next one is the about page. Here I can sign in and log into my dashboard. So I'll be giving some user ID and password and login. So as we logging into the dashboard, we can see here about the project, about the object detection, and all the graphs will be displayed here. And next one is the notebook. It displays the project code. And let's see how the drone can be detected. So in home screen, we can choose the file here, and these are the images. I'll be selecting one image, which is actually synthetic data image. So as I upload it, the drone is detected here with a probability. I'll be detecting the another image. So this is taken from a video, and as I upload, the drone will be detected with giving a 8.09 as a probability. So this is how the execution part goes. Conclusion. In my project, I used a texture invariant object representation for aerial object detection. I created a synthetic data and synthetically generated dataset confirms that shape plays a greater role in aerial object detection. So I have used a randomly assigning typical texture to UAV models to create a synthetic data. And synthetic data is very quantitative and qualitative compared to the real world data, and it is very cheaper than real data. Future scope. As current results are not conclusive, they can further investigate to what ability generalization can be done on unseen data. And the another one is at how much extent the degree of data diversity contributes to the performance. These are the references which I referred for my project.